Welcome back to part 2. So let's talk about how we graph roses in calculus. Now most time in calculus we really only want one petal, so this technique is really easy for us. If I want to graph a rose, the first thing I recognize is the number of petals. And you should remember that in an odd number of petals, if there's an odd number in front of theta, it's telling me that's the number of petals. So this is a 3-petal rose. So if I want to graph this, if you remember how petals look, they always look something like this, right? A rose always looks like this. What I want to find out is where the radius equals 0. And that's going to help me determine what the graph looks like. Now you might recall we did that up here when we talked about the loop of our looped lemmason. Finding out where that radius is 0 really does help us. So because what the loop tells, so if I start here, remember when I graph it, I'm starting where my radius is 0, and I'm going to end my petal also where the radius is 0. So where I start and end, and both places the radius is 0. And I'm going to use that to help me graph. So let's see here. If I set my radius to 0, we get sine of 3 theta equals 0. I can solve this. Where is sine equal to 0? Well, sine is 0 at 0 pi. Now remember, I've got to go around the circle quite a few times. 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. I had to go around 3 times because I'm going 3 times around. I got this 3 theta right there. And if I divide by 0, 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, and 2 pi. When I graph this, remember, I'm starting here at 0. Does it make sense? I'm starting at 0 degrees, or radians, excuse me, and this tells me where my petal starts. Well, when is the next time my radius is 0? At pi over 3. This is where my petal ends. So between 0 radians and at some pi over 3 radians, I have a petal. It goes out, like so. I'm starting at 0, and I end up at 0. Well, what about the next one? Well, take a look. When is the next time my radius is 0? Here. So I'm going to start at 2 pi over 3. Where do I end? At pi. So between 2 pi over 3 and pi, I have my next petal. Whoop, that's doing terrible there. So there's one petal. There's our second petal. So where's our third petal at? Right here. Where do I start? 4 pi over 3. Where's it ending? 5 pi over 3. So my petal has to go out in the middle there. And there we have it. Now notice I'm not worried about the radius because we're really only kind of rough sketching this. What about the 2 pi? Well, 2 pi is my start. It's at 0, so it's just going to start over again. Will this work for other ones? Well, what if we did something like r equals cosine of, let's say, 2 theta. Now remember for this one, if it's even, we have to double. So this has 4 petals. Okay? Now cosine's a little bit different. If I set this equal to 0, we get the cosine of 2 theta. Now, where in sine, the first petal is always in the first quadrant. In cosine, the first petal is on the x-axis. So that's going to change a little bit different for us. So let's take a look here. So we would get 2 theta equals, where's cosine 0? Pi over 2, 3 pi over 2, now I have to go a little bit further, 5 pi over 2, 7 pi over 2, and notice I left a bit of a blank space here. Because it has to be on the x-axis, cosine I actually start off at negative pi over 2. And I'm going to keep going here. Let's see here. So if I go, let's go a little bit further. So if I now divide by 2, I get negative pi over 4. 7 pi over 4, 3 pi over 4, I forgot to count on Sesame Street, 5 pi over 4, whoa, 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 and 7 pi over 4, whoa, whoa, whoa. That's awful. Alright, so when I graph it, so let's just graph the first petal. Because in calculus, that's all we really want. So, if I graph this, I'm starting at negative pi over 4, and my next petal ends at 5 pi over 4. So I'm sorry, this is terrible. Sorry, that's terrible. So my petal starts here at negative pi over 4 and ends at pi over 4. I messed it up here. So it ends at pi over 4, and that's how far out it goes. Far out, man. My next one. Now, be careful. Cosine is also a little bit different. Where in sine we can just do them individually, like these two, these two, these two. With cosine, they will kind of overlap. So like there's my first one. My second one would be this. So this is a really kind of an interesting way to graph these. But remember, most of the time we only want the one quadrant, because if I want to find the area of the one petal, if I want to find the area of the whole thing, I just take this petal. I can just multiply it by 4. All right. Hope you enjoyed the video. I will see you soon. Bye bye.